Okay, so we looked at diamond problems and that pattern. So let's remind ourselves of the pattern. We have a factor and a factor, and on this side we're going to multiply the factors, and on this side we're going to add the factors. Now, if we think about the way that it works when we multiply polynomials, if I have x plus 2 times x plus 7, when I multiply these together, x times x is x squared, x times 7 is 7x, 2 times x is 2x, and 2 times 7 is 14. So we can see that I end up with 9x plus 14. The middle term is where these two numbers are added, and the end term is where these two numbers are multiplied. So if we take the same idea, a and b are multiplied and a and b are added. So on this problem, if I put my 13 here and my 42 here, I need to find two numbers, two factors that multiply to make 42 and add to make 13. Well, that would be 6 and 7. So I can rewrite this in my factored form with parentheses as x plus 6 times x plus 7. Let's try it again. Here I have 8 and I have 7. I just take these numbers in order. This is always going to be my multiplication, and this is my, the product of multiplication and the sum of addition. So here I need two numbers that multiply to make 7. Well, that would have to be 1 and 7. 7 is prime, so that's my only choice. Let's check and make sure it works. 1 times 7 is 7. 1 plus 7 is 8. So that works. So I can rewrite this as x plus 1 times x plus 7. Another example. If I have 2 and negative 24. This one's a little different because there's lots of options for 24. So let's think about what those are. And it's negative, but I'm just going to start with the factors of 24. So I have 1 and 24, and I have 2 and 12, 3 and 8, 4 and 6. Now I know if this is negative, one of these has to be negative and one has to be positive, which means the difference of these two numbers is actually what's going to get me here. So which of these are 2 apart? It'd be this one. They're 2 apart. And this is positive, so the bigger number has to be the positive one. So this is going to be 6, and this is going to be 4. So then I can write this x minus 4 times x plus 6. All right, here's another example. Now this one's a little tricky because it doesn't have the middle term. But if we think about this, it's actually 0. We have no x terms, which means our middle coefficient is 0. We just don't write it because 0 times anything is 0, and we don't have to write that. But if we think about this, this is 0, and this is negative 16. So I need two numbers that are going to multiply to make negative 16 and add to make 0. For them to add to make 0, they need to be opposite numbers. And the opposite numbers that make negative 16 are 4 and negative 4. So x plus 4, x minus 4. Okay, and this works for any quadratic where there isn't a number in front of the very first x. So here, because these all are basically 1x squared at the beginning, this diamond problem will work. All right.